This is RD Sharma Solution, Class 12th, Chapter 9. Continuity exercise is 9.2. So before we go ahead solving this exercise, there are certain things which you need to understand. There are certain intervals, closed interval and open interval, where the function it will be continuous, where it will not be. So for open interval, if it is continuous, we write like this, round bracket a and b. So between a and b, that means every point starting from a till b, at every point this function has to be continuous without any break. Here the same thing goes for because we are talking about two intervals. So this is the closed interval, square bracket, closed interval. So when the function is continuous in this closed interval, there are three conditions. The first one, that is, it has to follow that in open interval it has to be continuous. The second condition is this a and b. So limit a plus, that is from a and above. If you take the value of the function, it has to be fa, the value of the function at a. So this is the second condition. The third condition is the limit b and below, that is on the left of b. So limit b minus the fx, the value of the function at x, is equal to fb. So the closed interval and the open interval, the continuity will be subjected to or will be defined by the discussion we just had, right? So whenever we see that a function is continuous, there is a domain, that is, there are functions which are continuous everywhere, but like minus infinity to infinity, these are continuous and there has to be a domain. So this domain is continuous everywhere, but there can be some domains, say 0 to pi by 2 or pi by 2 to minus pi by 2. There are domains also. Okay, let us take the properties of the continuous function. For example, we have a function say f. There is another function called g. More precisely, they are fx and gx. So when they both are continuous, then under some boundary or some domain, there are certain properties these two functions follow. That is, when you add these two, when you subtract these two, when you multiply these two, when you divide these two, when you multiply a scalar, say alpha or k, with any of the function, or division as I just indicated, or you can take 1 by f or 1 by g. The only last two, the g should not be 0 and f should not be 0, or gx or fx should not be 0. Okay, so when the function are added, when these two functions are continuous under certain domain, all these will be also continuous under that domain. Then we talk about composition, that is FOG and GOF, f of gx and g of fx. If fx and gx are continuous, then f of gx and g of fx, they both are continuous as well. They also follow the concept of continuity. Remember, f of gx and g of fx. Okay, so these are certain properties of functions which are continuous at certain domain. Now coming to there are certain functions which are continuous. So when we will discuss the question, you need to know that there are certain theorems. We don't need to prove it here, they are in the book. So modulus function or absolute value function, it is function, this modulus value of modulus is continuous if this fx is continuous. Then we have the continuous continuity for constant ones, that is fx equals c, constant, 2, 5, 6, these are all constants. So it will be constant everywhere, this constant function. It will be actually a straight line. It is y equal to c, it will be a line parallel to x axis. Then we have the identity function y equals x. This is the graph, or you can say straight line of this function. This is the identity function. This is also continuous everywhere. Along with this, we have, say, for ax square plus bx plus c. So this is a polynomial. So a function, polynomial function, is also continuous everywhere. So it can be a one order, two order, or multiple order function. So whenever we do the question, whenever this comes, polynomial comes, we'll directly say that okay, this polynomial is a continuous. So we need to see, and we need to just understand that these are continuous function. We don't have to prove it. Okay. So when fx and gx are continuous, what will happen? Fx and gx, because fx by gx, when we do, we need to know the domain of gx also. That is, they will be continuous but under certain domain. That has to be very clear. A to the power x is continuous, but the only condition is a should be greater than 0. Then continuity will follow. E to the power x, this is also continuous. When e to the power x is there, consequently log x will also be like that. So a to the power x, e to the power x, and also log function, log x function, this is also continuous, right? Okay. Coming to sine, cosine, and trigonometric function, you can say. So sine and cosine, they are continuous everywhere. Sine and cosine are continuous everywhere, but tangent is continuous but in certain domain, and you know that domain if you have done trigonometry properly. That tan, that has to be under certain domain. But when we talk about cosine, or this 1 by sine, 1 by cosine, 1 by tan, that is secant, cosecant, and then we have the cotangent. So they are also continuous, but we have to define, and we should know under what domain, right? When we talk about inverse, so inverse, when we know sine only goes from -1 to 1. So the sine inverse x, fx equals sine inverse x, this will be continuous when this is -1 to 1. So this is the interval. So this is a square bracket, and you know what kind of interval this is. Okay? Because this square bracket, this is closed interval where these are included, -1, 1 are included. Okay? So these are the basic things you need to know before attempting the exercise. Okay? So let us apply this. Starting with the first question. Prove that the function fx, which is sin x by x and x plus 1. So sin x by x, x is less than 0, and x plus 1 is x greater than or equal to 0. So x is the point of contention. When we go on the left hand side, it is sin x by x. On right hand side, it is going to be x plus 1. Okay, the first thing is, we have just discussed that we have to prove in this question that this is everywhere continuous. But what we discussed just now, that sin x is continuous. When we are talking about x less than 0, sin x is continuous. X is continuous, we have just seen now. So division, you can call that numerator as fx and the denominator as gx. So fx by gx, if gx is not equal to 0, then it is continuous. Okay? Fx and gx both are continuous. So this is what you have to write. You can call it as a quotient function because it is the form of f by g. Now coming to x greater than 0, x plus 1, fx is x plus 1. So when this y is x plus 1, this is a polynomial of first degree. And all the polynomial function, they are continuous, as we just suggested. So this, when x is greater than 0, we have fx equal to x plus 1. Therefore, fx is continuous at each x greater than 0. Now the part which question is asking is prove that the function fx is this all x less than 0, x greater than 0 is everywhere continuous. But this thing with the way is same. What we are going to do, we are going to find out the LHL, RHL and the value of the function at 0. So if they are equal, then it is continuous. You can very well prove that it is continuous at 0 also, because this is the point they are asking. So let us check the left hand limit and right hand limit. And since we have already defined it, that x equals to 0, left you go, it is sin x by x, right you go, it is x plus 1. So LHL is on the left, that is 0 minus h. RHL is 0 plus h. So the LHL will be 0 minus h, we'll take it as minus h. RHL is, we are taking x as 0 plus h, so you can take it as h. Now just put this minus h in sin x by x, x less than 0. In x greater than 0, we just put this as h. So this is sin minus h divided by negative. So we have negative h here. So negative h. Okay. Here we have this x plus 1. So you can just write h plus 1. You know that sin negative theta, sin minus theta is minus sin theta. So you can write it as minus h sin h divided by minus h, and minus minus gets cancelled. Now apply the limit. This also we know. Here also we will apply the limit. Limit h theta tends to 0, sin theta by theta is what? It is 1. Here also h equals 0. So it is 1. So left hand limit is 1. Right hand limit is 1. And what is the value of the function at x equals 0? We have to use x plus 1 here. So f0, just put it here. In place of x, replace it by 0. 0 plus 1 is x plus 1. I am replacing x by 0. So it is 1. So left hand limit, right hand limit and this one, the value, they all are equal. Okay. So you can say that this at 0, this function is continuous. Discuss the continuity of the function. Now you see here fx, x and mod x. You have to view them separately and then see, because we have these properties and attributes we just saw. So x equals to 0 is the point of contention. When we go on the left hand side, you have to take x by mod x. Mod is absolute value basically. So x by mod x. On the right hand side also you are going to use the same thing, because when x is not equal to 0, you have to use these. Okay. Now when we just go ahead, just see that is x by mod x. Fx you can call it as x, gx you can call it as mod x. And individually this x, y equals x, we have just seen that this is continuous everywhere. Also the mod x is continuous everywhere. Y equals to x is simply first order polynomial. And y equals mod x, which is the absolute value of x. And this function is also, we have seen that it is continuous. But there are points where it will not be continuous. And we'll check it at 0 here. Right? So let us see at this point on both of this. For that, what we are going to do? We are going to apply the left hand limit and right hand limit. LHL and RHL concept we have already seen in the previous exercise. We have done more than 44 questions. Okay. So we will just do the same concept here, but you may write as given in the question that what is mod x. Mod x I have already shown you that mod x is x when x is greater than or equal to 0. It is negative x when x is less than 0. Right. So x is equal to 0 minus h at left hand limit. X equals 0 plus h at right hand. Let's just put this 0 minus h and 0 plus h. Okay. Let me write this. Because we are using minus h and h, I am putting it here. Minus h divided by mod of minus h. Here h divided by mod of h. Mod is absolute value. So positive h will come out. Here h by h. You can cancel it. It is negative 1. You can cancel it. It is going to be 1. Now what do you see here? The left hand limit and right hand limit, they are not equal. So when they are not equal, that means at 0. See, x is continuous everywhere. Mod x also we talked about that. But when we take x by mod x and we are specially checking at x equals 0, So it is discontinuous at x equals 0. So you can check the value also. It is already given at 0. The value is 0. So it is not -1, 1, 0. They are entirely 3 different values. It is discontinuous at x equals 0. Okay. But if you want to write more, because you can elaborate the things every time just to please your examiner, then what you can do? Mod x is x when x is greater than 0. Mod x is negative x when x is less than 0. And since the value of fx will at x greater than 0 is 1, we have found out. At x less than 0, we have found out it as negative 1. At x equals 0, it is equal to 0. That also we have shown, right? So this is how you can write to make the answer or your solution more effective. This is how we do the things. Okay. So this is one of the types of question, and there are questions coming which are of the same type. That is, we have multiple question of this 3.1, 3.2, etc. So find the points of discontinuity, if any, of the following functions. First concept is very clear. When x is not equal to 1, what we are going to do? We'll use this polynomial. X cube minus x square plus 2x minus 2 on both the sides. Because when x is not equal to 1, this is the, say, expression, or you can say the polynomial we are going to use. So this function is a polynomial and it is continuous everywhere. Then first you have to write that. So it is continuous at every point. It is everywhere continuous. And we will, since the question is that there are two things being given. Since x not equal to 0, this is given. But when x is equal to 1, it is already given that it is 4. So we have to check whether it is also saying the same thing. Because continuity, discontinuity, we have already seen. But when the question is saying that, okay, check it at when x equals to 1, it is 4, then say whether it is continuous or not. So LHL, RHL will do. We'll use 1 minus h because we have to check at x equals 1. So we'll just place x equals 1 minus h on the left hand side. And here we will put x as 1 plus h on the right hand side. So this is x cube 1 minus h whole cube minus 1 minus h whole square plus 2 into 1 minus h and minus 2. This is your LHL. And RHL, same thing. In place of x, just put 1 plus h. So 1 plus h whole square minus 1 plus h whole square plus 2 into 1 plus h minus 2. Now there are two ways. Either you open all these, cube and square, etc. But I'll just tell you the shortcut. Just apply h tends to 0 here only. Just make it as 0. You'll get the same answer. So 1 minus 1 plus 2 minus 2 here. So it is going to be 0. Right hand side, again apply h tends to 0. So 1 minus 1 plus 2 minus 2. Again it is 0. Okay. Now since we said, okay, it is continuous everywhere, this polynomial function, it is okay. Since the question is also saying that when it is x equals 1, that is f1 is equal to 4. It is given in the question itself. That means the left hand side and right hand side are meeting, but the value of the function at 1 is 4. So it is discontinuous at x equals 1. So the only point of discontinuity for this function fx is x equals 1, because the question has been formed in such a way that it is not continuous at x equals 1. Find the points of discontinuity, if any, of the following function. This fx is given when x is not equal to 2 and when x is equal to 2. The point of contention or checking is 2. So x equals 2. When you go on the left or right of that point, x equals 2, then we have to use this function x raised 4 minus 16 by x minus 2. The value of the function at 2, that is f2, is 16. So in order to discuss the continuity and discontinuity, first of all, we have to see that x4 minus 16, this is a polynomial function. The x minus 2, again a first degree polynomial function. And since both are polynomial function, fx by gx, the division is also a continuous function. Okay. So we have to, this denominator, we can do what? We can simplify it so that we can go ahead with the checking of LHL and RHL, that is left hand limit and right hand limit. So let us first of all simplify it. X raised 4 minus 16 it is. So we can write it as 2 raised 4. Denominator we have x minus 2. So x square whole square minus 2 square whole square. So I am doing the numerator. So it can be written as a square minus b square. So a minus b, a plus b. So x square minus 2 square into x square plus 2 square. Okay. Now this can also be written as a minus b, a plus b. So x minus 2 into x plus 2. And then we have x square plus 2 square, that is 4 you can write. In the denominator, we have x minus 2. So you can cancel these x minus 2. Now finally we have x plus 2 into x square plus 4. So this is also polynomial, and multiplication of two polynomial will always be continuous function, as we have discussed in theory. So let us take the LHL and RHL. In LHL, because the point of checking is x equals 2. So 2 minus h we have to use here. X equals 2 minus h. On the right hand side we will use x equals 2 plus h. Okay. So let us put this value in x plus 2, x square plus 4. So I am putting 2 minus h on the left hand side, LHL. Same thing, but here we are going to put 2 plus h here. So 2 plus h and plus 2. And this x square plus 4, so 2 plus h whole square plus 4. Okay. Now either you open it and put h equals 0, or you can put h equals to 0 directly here only. So what do you get? 2 and 2 are 4. This is 2 square plus 4, that is 8. 8 4 is 32. Limit h tends to 0. Here also we have 2 and 2, so 4. And then you have this h as 0, so 4 plus 4, that is 8. So 32 on both the sides. That is fine. But the thing is that LHL, RHL, when we talk about, the value of the function at x equals 2 is 16, not 32. Find the points of discontinuity, if any, of the following functions. This is given when x is less than 0, it is sin x by x. When it is x greater than or equal to 0, it is 2x plus 3. So what do we have here? We have the sin x. Sin x, we know that it is continuous everywhere. X is also continuous everywhere. X is, you can call it as an identity function, or you can call it as a first order polynomial as well. So fx by gx, when you have fx and gx separately, they are continuous everywhere. When you divide them, then also they are continuous. 2x plus 3 is a straight line, is a first order polynomial. So this is also continuous. So this discussion you can write here. First thing you have to write in solving this type of questions. Then the second step is to find out the actual continuity or discontinuity at x equals 0. So at left we'll take 0 minus h, right we'll take 0 plus h. So we'll use this sin x by x. So here we'll use sin minus h by minus h. Here we are going to use what? This is h, so 2h plus 3. Sin minus theta is minus sin theta, so you can write minus sin h divided by minus h. So just cancel these minus out, 2h plus 3 here. Okay, let us apply limit h tends to 0 on both the sides. Sin theta by theta is 1. 2 into 0 is of course 0, so you get 1. So LHL and RHL are not equal. They are themselves not equal, right? if you want to find out the value also, that is f0, just put x as 0 in this 2x plus 3. So 2 into 0 plus 3, what do you get? You get a 3. Okay. So what do you see? They are not equal. All three should be equal. So it is discontinuous at x equals 0. Find the points of discontinuity if any of the following function. Now same discussion here. X is 0 is the point of discussion or contention, and since at x equal to 0 already 4 is there, sine 3x is a sine function, so it is continuous everywhere. X is again an identity function, or you can call it as a first order derivative, first order polynomial also. So they both are separately continuous, and if you take the quotient, that is fx by gx, they also will give you the same result. And the value which is constant 4, which is actually a line parallel to x-axis. So let us take 0 minus h and 0 plus h on LHL and RHL, and this sine 3 in place of h x I am putting minus h. Here right hand side again in place of this x I am putting h. So sine minus theta is minus sine theta. So this is minus sine 3h divided by h. So you have to introduce a 3 here. Multiply numerator denominator by 3. Sine theta by theta. This is sine theta by theta, and it is going to be 1. Limit theta tends to 0, or h in this case h tends to 0. So you have 3 and 3 on both the sides. That is LHL and RHL are equal. But the point is that x equals to 0, at x equals to 0, the value of 0 at the fx at 0 is 4. It is not matching with LHL and RHL. So it is not continuous. Discontinuous at x equals 0. Find the points of discontinuity if any of the following function. So this also we are going to do in the same way. Just remember, when we have various functions which are continuous by itself, and when we combine them, say in the form of division, in the form of addition, in the form of multiplication, they will still remain continuous, as we discussed in theory. Sin x is continuous, x is continuous, sin x by x is continuous. When you add two continuous functions, that is cos x and sin x by x, in turn they will also be continuous. Okay? So when you add them, cos x and sin x by themselves are continuous. So assume these two separate functions, or you can call it three functions, fx, gx, and you can say rx, sin x, x, and cos x. So they all are continuous by themselves. Along with this 5 is also continuous because it is a straight line which is parallel to x-axis, right? So remember, fx equals 5, that is y equals 5, is simply a line which is parallel, and that will always be continuous. A straight line is always continuous. There is no break. So this all you can write. The way of writing I showed you here on the left. And we need to check for the continuity as well. So at x equals 0, we have to check. It is already given that the value of the function at x equals 0 is 5. We go left, we go right. So when we go left, we have to put 0 minus h. Right, we will put 0 plus h. Okay. So this is sine minus h. I am replacing x by minus h. Plus cos minus h. On right hand side, you don't have to do anything. It will always be 5. Okay. No. It will be sin h by h plus cos h. I'm so sorry. I changed my sentence. So both sides, just put minus h and h. So sin minus theta is minus sin theta divided by minus h plus cos. Cos minus theta is plus cos theta. So what do you see? Right hand side and left hand side, they both are equal. They are same. Sin h by h plus cos h, both the sides. Apply the limit. Limit h tends to 0. What do you get? This is sin theta by theta, which is going to be 1. And cos 0, that is cos 0 is 1. So 1 plus 1. So both the sides will get 2. LHN and RHL you will get 2. Okay. But the value of the function at x equal to 0 in this question is given as 5. So they are not matching. So fx is discontinuous at x equals to 0. Hence the only point of discontinuity for this function fx is x equals 0. Okay. So when we combine, see, separately the functions can be continuous by themselves, but when we combine them, then we need to see how they turn out to be. Again, the points of discontinuity for this function, fx equals, there is a proper function given when x is not equal to 0, and since tan inverse x is there, tan x is continuous not everywhere but at a domain. Sin x and cos x, they are continuous everywhere. Tan x is not continuous everywhere. It is continuous at particular domain. This need to be very clear. The polynomial function, of course, the numerator is continuous everywhere. Okay. But tan inverse x, when we talk about the domain, since we know that sin inverse x, for example, -1 and 1, that is the domain of it. So when we take fx by gx, don't worry about anything about tan inverse x, because tan inverse x cannot be 0 when we talk about fx by gx. P by q form, q should not be equal to 0. That is the only point we discuss. So tan inverse x, it should not be equal to 0. That is the only thing. Okay. But now talking about the continuity or discontinuity, the process is same. There is no difference which we already, in the past we have done. We will check at 0 minus h, 0 plus h, x equal to 0. 0 minus h, 0 plus h, so x at x equal to 0 it is already given as 10, so f0 is 10. Okay. So whether you get the value LHL and RHL equals to 10, that will decide the continuity and discontinuity. So x equals 0 minus h I am giving, x equals 0 plus h I am giving these values. So x raised 4, so minus h to the power, this is minus h only, this is plus h. Minus h to the power 4 plus h to the power minus h to the power cube plus 2 minus h to the power square. Now whatever you do here, I am doing it, you are also watching. But the thing is, the numerator is always h. There is always h. There is no h in the denominator to cancel it out as well. So it will always be 0. Whether you place anything, you take something common, try to cancel it out, but whatever you do. This is right hand side I am doing, that is the RHL I am doing. I am putting h. Left hand side we place minus h. Okay. Now you see this tan inverse minus h or plus h, whatever you do. On the right hand side you have to put plus h. So that is a correction here. So when you put h equals 0, it will be 0. Numerator, h is 0. H is always there. So as I said, the denominator, don't worry about that. The numerator itself is saying 0. Okay. And tan inverse h divided by h, if you even want to go further, tan inverse h divided by h, that is going to be 1. So apply the limit in the denominator, introduce a h, try to cancel a h in the numerator, but that is not going to affect, because still we have h cube plus h square plus h in the numerator. Okay. So what I am trying to suggest here is tan inverse h by h, of course when you apply the limit in the denominator it is going to be 1. But numerator will always be 0. So left hand side and right hand side both will be 0. And what is the value of the function at 0? It is 10. So that is discontinuity. Find the points of discontinuity, if any, for the following functions. Now discontinuity or continuity, first we need to know that what are the functions being given in the question. The question is saying e to the power x minus 1. But we know that e to the power x minus 1, this e to the power x by itself is continuous. Log x is by itself continuous. They both functions are continuous. E to the power x, e to the power x, log x, all these are continuous. But when we divide them, they will also be continuous because it is p by q form. But the value of the function at x equal to 0 is 7. So whether the limit of this function is matching with 7, that will decide the continuity or discontinuity of this function at x equals 0. Okay. So we'll apply a direct limit. Don't worry about LHL and RHL here, because you'll see what will happen. E to the power x minus 1. Now e to the power x minus 1 divided by x, limit x tends to 0 is 1. We have already seen in many questions. So e to the power x minus 1 by x, multiply numerator denominator by x, introducing x. Log 1 plus 2x. So log 1 plus theta divided by theta, limit theta tends to 0 is 1. That also we have seen. Or you can call log 1 plus k by k, limit k tends to 0. Okay, this is also 1. So introduce a 2x, introduce 2x in numerator denominator. Now just apply the limit. So when you apply the limit, e to the power x minus 1 by x and log 1 plus 2x by x, both are going to be 1. This is 1, this is 1. X gets cancelled, you get 1 by 2. Okay. So this is 1 by 2 is the value of the function at limit x tends to 0. But what is the value of the function at x equal to 0? It is 7. f0 is 7. It is not matching with half. So this given function is discontinuous at x equal to 0 and it is continuous everywhere. Find the points of discontinuity, if any, of the following functions. So there are certain things you have to write upfront, and these are the modulus function or absolute value function. This is continuous. We know about that. We discussed it earlier. And this function is a polynomial function. And since this x square, 3x and 13, all these are individually continuous functions because they are polynomial functions. So we can say that these are polynomial functions and absolute, so they are continuous. So we have to check at x equals 1. So when we go, on the left hand side, we will use this function. On right, we are going to use this modulus function. So one time polynomial, one time modulus. So x equals 1 minus h on the left, x equals 1 plus h on the right. So this is 1 minus h whole square by 4 minus 3 into 1 minus h divided by 2 plus 13 by 4. This is x equals 1 minus h. Now let us place x equals 1 plus h. So 1 plus h minus 3 it is. So rather, opening it and keeping h equals 0, you can directly put limit h tends to 0 in both the sides. So this will be 1 by 4. This will be 3 by 2. This will be 13 by 4. Okay. When you take the LCM and solve it, it is going to be 2. On the right hand side, h is 0. So 1 minus 3 is negative 2. And when you take the modulus, it will be 2. Okay. Now left hand limit and right hand limit, they are equal. But still one more thing has to be checked at x equals 1. So this will be mod x minus 3. So f1 we have to find out because this is the equality sign. And for this we are going to use this mod x minus 3. So 1 minus 3 it is, again minus 2 modulus, so it will be 2. Now what you see here is the left hand limit and the right hand limit, and the value of the function at 1 is 2. That is, this given function is continuous because all these are continuity points. Find the points of discontinuity, if any, of the following functions. Okay, so there are 3 separate functions, and these separate functions are individually, they are continuous. We have to check at 3 and minus 3 as well. That is, if you start with this real number real line, so 0, just to show that how the line goes, negative 3 on the left hand side, positive 3 on the right hand side. Okay. So when x is less than minus 3, when you go this side, on the left hand side, you are going to use mod x plus 3. When you go up minus 3, that is on the right hand side of minus 3, so you are going to use minus 2x. And please remember, all these 3 functions are individually continuous, that you have to write. That you can write. I hope you'll be able to do that. Okay. Because mod x is continuous, 3 is a constant function. So when you add it, then also it will be a continuous function. We have minus 2x. This is also a polynomial function. Basically, you can call it as a straight line also. 6x plus 2 is also a straight line, but it is also a single order polynomial function. and we know that they are continuous, right? So this you have to write from here to here. All these points you have to mention here. This is mandatory. And then you come to the point at -3 and 3. And you need to check at both the points. Okay. So -3, x equals -3. And what we are going to do is left hand limit and right hand limit. What is left hand limit? Because it is -3. So x will be -3 minus h. Right hand limit will be -3 plus h. Okay. Now this is -3 and you have to do this same activity for +3 also. This is -3 minus h. We are using mod x plus 3. Here we are going to use -2x. We are going on the right hand side. So it will be -2 into -3 plus h. Okay. Either you put h directly here as 0, or you can open it and keep it h equals 0. Both ways you can do. So the best idea is to take 0 here only, because there is no other simplification possible. It will be -3 modulus is 3. 3 plus 3 is 6. Here it is 0, so minus plus reduces 6. Okay. The left hand limit and right hand limit, they are equal. Now equality sign is at mod x plus 3. So let us check it. The value of the function at -3, it is mod x plus 3. So mod, put it -3 here. -3 will be +3. And we have a 3 here. So this is going to be 3 plus 3, which is going to be 6. Okay. Now what you see here is all the three values are same, and this is the point of continuity. This function is continuous at x equals -3. How about checking it at 3? Because both the points you have to check. So LHL, what are we going to write? LHL we will put 3 minus h. RHL will put 3 plus h. And left hand limit, right hand limit, 3 minus h, 3 plus h. So -2 into 3 minus h will put here. And right hand side 6x plus 2, we are going to use this function 6x plus 2, because we are taking the point of contention is 3, so left right of that, and accordingly we'll use the function as 6 into 3 plus h plus 2. Now put h as 0. What do you get? -2 into 3, so -6 it is. And then we have this 0, so 6 is 18. 18 plus 2. So do you think there is any need of checking the value of the function at 3? Because the left hand side and right hand side, they are not equal. When both the values are not equal, you can very well say that -3 is the point where there is a discontinuity. But still we'll check for f3. This is 6. Equality sign is where? It is not given. But just assume that it is add x greater than or equal to 3, 6x plus 2. So 6 into 3 plus 2, that is 18 plus 2, that is 20. So it is matching with the right hand side, right hand limit. But still the left hand limit and right hand limit, they are not matching. So when they are not matching, you can very well say that 3 is the point of discontinuity. And on the other hand, -3 is definitely the point of continuity. So there are several questions like this, and I will encourage you to check for both the points of contention, not just one. Okay, you see in the solution it is only being checked for 3. Find the points of discontinuity, if any, of the following functions. So fx is this. So let us, first of all, you have to write all these. X to the power 10 minus 1, x to the power 10 is a function which is continuous. Then 1 is continuous, x square is continuous. There are certain ways also, you see on the left hand side I have showed you. This is also a way to actually solve this type of question. But we will do what? We'll follow the same routine or the procedure we used to follow in the earlier discussions. So x10, 1, x square, x10 minus 1, all these are continuous. But we'll check the discontinuity at x equals 1. And we'll go on the left hand limit, we'll use x raised 10 minus 1. On the right, we are going to use x square. So we'll check at 1, so 1 minus h on the left hand side, 1 plus h on the right hand side. So we'll put this x 1 minus h to the power 10 minus 1. Here we'll place 1, this is x square, so 1 plus h whole square. So this just put h as 0 here on the left hand side and right hand side, so it will be 1 raised 10 minus 1. So 1 minus 1 is 0. Here h is 0, so 1 square is 1. Okay. Now 0 and 1, they are not equal. So would you like to find out the value of the function at 1? It is not required, but just for the sake of completion we have to do. So we will find out the value of the function at 1, that is f1. It is x raised 10 minus 1. So just put 1 raised 10 minus 1. So this is also going to be 0. 1 minus 1 is 0. But still all the values are not equal. That means this 1, x equals 1, is the point of discontinuity. Okay, I hope you got the idea. It is point of discontinuity. Find the points of discontinuity, if any, of the following function. So I'll just leave it for you. I hope you'll be able to do this question. So you have to check it for 0, you have to check it for 1. Both points check. 2x polynomial, 4x polynomial, 0 is a constant function. So they all are continuous. Find the point of discontinuity, if any, of the following function. Fx is sin x minus cos x when x is not equal to 0, and sin x is continuous, cos x is continuous everywhere, and when we have fx and gx as sin x and cos x, fx minus gx, which is sin x minus cos x, this will also be continuous. This you can very well write. Along with this, we have when x is equal to 0, then it is given as negative 1. Minus 1 is a constant function. So all these three are continuous by themselves. But we have to check the continuity or discontinuity at x equals to 0. So we'll go on the left, it is 0 minus h. We'll go on the right, it will be 0 plus h. So it will be sine. Let us put it here. Sine, in place of 0 minus h, just you can replace it by minus h. So sine minus h minus cos minus h. Here it is minus 1. So you don't have to do anything here, it will remain as constant. Sine minus h, sine minus theta is minus sine theta. So it is minus sine theta, minus sine h. Cos minus theta is plus cos theta. So it will be cos h. What is this? Sine 0. I am applying the limit here. It is going to be sine 0 minus cos 0. Now sine 0, cos 0 is 1, sine 0 is 0. So 0 minus 1 will be equal to minus 1, negative 1. So negative 1, both the sides. One step is still remaining. We'll check the value of the function at x equals to 0. And it is already given as minus 1 in the question. That is, x is 0. So you don't have to do all this, which I am doing right now. It's already given at x equal to 0, the value is minus 1. So minus 1, minus 1, minus 1, all these are same. So it is continuous everywhere. So this is also the same type of question. Okay. So minus 2, 2x, the minus 2 is a constant, 2 is a constant, 2x is a first order polynomial, and these all are continuous. This you have to write everywhere. Okay. But you have to check the discontinuity or continuity of this function at x, which is equal to 1, and x equal to minus 1. So these are the 2 points. So accordingly you have to choose the function also. So x minus 1, when you go on the left, it will be negative 2. X equals minus 1 minus h we will put. X as minus 1 plus h will put. Left hand side, don't worry about that because it is already a constant minus 2. But on the right, what it will be? It is minus 1 plus h, so 2 into minus 1 plus h. So it is negative 2 already on the left hand limit. Apply this right hand limit h0, so it is negative 2. So LHL and RHL are equal. Okay. So f minus 1, the value of the function at minus 1, it is already given as minus 2. LHL, RHL and the value of the function at -1 is -2. So this function is continuous at x equals -1. But whenever we talk about x equals 1, then we have to check there also. On left hand side, we are going to take 1 minus h. On right hand side, we are going to take 1 plus h. And when x is less than 1, it is 2x function you are going to use. On right, you are going to use 2. So 1 plus h you cannot put here. So it will remain as 2. Here you can put 2 into 1 minus h. So just apply the limit h equals 0. So it will be 2. 2 here, 2 here. And then we have the function value at x equals 1, which is already given as 2. So LHL, RHL and the value of the function at 1, they all are 2. So what do we find here? That at x equals to -1, x equals to 1, both ways, these functions are continuous. This actually fx function is continuous everywhere. All these you have to write, okay? That is -2, 2, constant function, 2x, polynomial function, this all you have to write. Okay, next is in the following, determine the value of constant involved in the definition so that the given function is continuous. Now, as per the definition goes, sine theta is continuous. 5x polynomial function is continuous. 3k is a constant, k is some constant. So we'll just apply the limit x tends to 0 for sine 2x by 5x and we'll equate it with the value of the function at 0. So f0. But the value of function at 0, f0 is nothing but 3k. It is already given in the question, it is 3k. So we'll apply the limit here and equate it to 3k. So sine 2x it is, we need to have a 2x in the denominator, or x is already there, we'll include a 2. Or we'll introduce a 2. So it is 2, x was already there. Now we have a 5 in the denominator, so 2 has to be taken up also because this 2 should be cancelled. Okay, now apply the limit, taking 2 by 5 outside, so limit to sine 2x by 2x. Okay, this is going to be 1. We know that sine theta by theta, limit theta tends to 0 is 1. So 2 by 5 it is. And it has to be equated with 3k. So k will be equal to 2 by 5 into 3. 2 by 15. K is 2 by 15. This is your answer. In the following, determine the value of constant involved in the definition so that the given function is continuous. So what do we do here? Because x, x both are here. And we'll take the limit and we'll just equate it to the other value which is at x equals 0. Okay. Left hand limit and right hand limit also you can find out. And then you can place it and equate it. So the point of check is x equals 0. So we have to go on the left hand side and the right hand side. So on left it will be k into x square plus 3x. On right it is going to be cos 2x. So left we will put 0 minus h. Right we will put 0 plus h. Let us put it here. K 0 minus h means minus h. Minus h whole square plus 3 into minus h. On right we have cos 2 into 0 plus h, that is h. Now k, since we have this h square plus minus 3h and we cannot get rid of this h anyways. So whatever you do, you have to put h as 0 when you apply the limit, and that is going to be 0 by itself. So the value which is having k as the content is becoming 0. On the right hand side, if cos 0 is taken, it is going to be, because cos 0 is 1. We are applying the limit here, limit h tends to 0. Cos 0 is going to be 1. So 0 is equal to 1. If LHL and RHL are equal, 0 is equal to 1 and we are not having k anywhere. So there does not exist any value of k which can make the given function continuous because of this contradiction or this inequality. Same thing we have to do here in the following. Determine the value of the constant involved in the definition so that the given function is continuous. So we have 2 points of check here, 3 and 5. And There are two constants here, 2 and 9, and ax plus b is having a variable x. So let me draw a number line, and it is 3 and 4, 3 and 5. So 3 and 5 we have to check. So 3 LHL RHL for 3, that is the left hand side, right hand side. Similarly for 5 also LHL and RHL. And we'll get some equation. We are going to solve that equation. Okay. So let us start with x equals 3. And we have to put 3 minus h for LHL. And then 3 plus h on the RHL. Similarly for 5 also we'll do that thing. But let us complete this 3 first. So x is less than or equal to 3. It is already a constant. So we don't have to do anything for this. On right hand side it is ax plus b. Because it is going above 3. And a into x plus b, x you can write 3 plus h, and this is a 3 plus h plus b. You just put 0 here, or you can open it and then equate it, then put the 0. It's one and the same thing. So this ah will, you can get rid of this ah. So 2 is equals 3a plus b, so 3a plus b equals 2. This is your first equation. And we are thinking on the right path because we are going to get an equation for x equals 5 as well. Same thing we have to do LHL and RHL. X is equal to 5. Okay. On the left hand side we are going to use ax plus b. On right we will be using this 9. 5 minus h, 5 plus h will put. But there is no point in writing anything or giving anything because it is a constant 9. Ax plus b, in place of x just replace it by 5 minus h. And then you have to equate it by 9. So 5a, h is 0, plus b is equal to 9. So both ways we get equation on left hand side, means x at x equal to 3, and another equation for x equal to 5. What is the equation here? So we have 3a plus b equals 2 and 5a plus b equals 9. So let us write 5a plus b equals 9 first, and then 3a plus b equals 2. Subtract these two. BB gets cancelled. 5a minus 3a is 2a. 9 minus 2 is 7. A is equal to 7 by 2. Now you can put this 7 by 2 in any of these equations which we just got, and you will get the value of b. I am placing it in 3a plus b equals 2. In place of a, I am replacing it by 7 by 2. 21 by 2 plus b equals 2. B equals 2 minus 21 by 2. So you get 4 minus 21 by 2. So 4 minus 21 by 2 is actually negative 17 by 2. This is your b value. So A and B, this is how you will find out the values in another questions which are coming up. So in the following, determine the value of the constant involved in the definition so that the given function is continuous. So we have minus 1 here, 0 here, and we have one constant 4, and one polynomial and one trigonometric equation, the trigonometric value. Okay. So let us check it at minus 1, and then we'll check it at 0, because these are the point of check for continuity and discontinuity, and since it is given already, it is. So x equals minus 1. On left we will write minus 1 minus h. On right we'll use minus 1 plus h. Since we will use 4 on the left and right, we will use ax square plus b. There is no point in putting anything for 4 because it is already a constant. So don't worry about that. It will be always 4. It is a constant. In place of x square in ax square plus b, just replace it by minus 1 plus h. And this is ax square plus b. Now just open it and place h as 0. But you can also put it here. It won't affect. This is 0. Minus 1 whole square is 1 already. So a plus b. So first equation what we got from x equals minus 1 is a plus b equals 4. Now coming to x equals 0. Then on left we are going to use ax square plus b, and this cos x will use for the RHL. But we'll put 0 minus h for LHL. So ax square plus b, and on the right we'll put 0 plus h in cos x. This is minus h, so a minus h whole square plus b. So it is basically a h square plus b. So when you apply the limit h tends to 0, it is going to be 0. And you just have to write b on the LHL. So only b you got. On the right, it is going to be cos 0 plus h, that is cos h. And cos 0, when we apply the limit, what I'm suggesting is we are applying limit also, that I'm not writing, but you have to write it properly. So cos 0 is 1, so b is 1. So a plus 1 equals 4. I'm putting b as 1. So a is 3. B is 1 and a is 3. This is your final result. Same thing we have to do here, because the given function is continuous. It is given, and you have to find out the value of the constant. What is the constant here? P. And we are in between -1 and 0 and 0 and 1. Okay. So we'll check for 0 here. And then we'll try to find out the LHL and RHL at 0. And the values are also given. That is the function value are given. So this is talking about 0, -1 and 1. If you have any confusion, just draw this number line. You will see where we have to check. Because here -1 below not given, +1 above not given. Only thing which we see is 0 left of 0 and right of 0. So x equal to 0 is the point of check. X will use as 0 minus h for left hand limit. For right hand limit, we'll use x as 0 plus h. And the functions are, because basically it is minus h and h only. So we'll use this function. The only thing is that this function will need some simplification. So I'm writing it as a 1 because I'm replacing it by minus h. So it will be 1 plus px, or 1 plus p into minus h. So it will be 1 minus ph. Similarly, minus under root 1 plus ph, because we are replacing it by minus h. And in the denominator, we have minus h. First, let us complete this. So we have this, so let us rationalize it. So same thing, same numerator with a positive sign, we are going to multiply in the numerator and denominator. So under root 1 minus h minus 1 plus ph, and minus h I am taking just to give a little bit of space. Under root 1 minus, same thing with plus sign, everything with same plus sign. But we have to multiply this in numerator as well and denominator as well, right? So once you do this, the numerator will be a minus b, a plus b. A minus b, a plus b is a squared minus b squared. And since it is root will get eliminated. You will get 1 minus ph minus 1 plus ph. Okay. This is numerator only I am doing. So 1 minus ph minus 1 minus ph. So 1 gets cancelled. You will get minus 2 ph. Since we have a negative h already there, you can cancel minus h minus h. So 2p is there. Okay. Since we have a 2p here, let us see the denominator, because some rationalization was done. Let us put h0 here. So 0, this is 0, under root 1 is 1, under root 1 is 1, 1 plus 1 is 2. So this denominator gave us 2. Now you can cancel these 2. So you get p on the LHL. Now on the left hand limit, you get p. Coming to the right hand limit. So we rationalize it. This is the only thing which will take some time. Right hand side, it is 2x plus 1 by x minus 2. Just put h in place of x and just replace h by 0, applying the limit. H tends to 0. This you have to write, okay? I'm just not writing, just to save some time. So 1 by minus 2 you will get. Now you equate p with minus 1 by 2 because it is continuous. So left hand limit should be equal to right hand limit. So p is equal to negative 1 by 2, and that is your answer. This is your final answer. In the following, determine the value of the constant involved in the definition so that the given function is continuous. Same thing we have to do. We have two constants here, 5 and 21. And if you have any confusion, draw a number line. So this is 2. And you have x less than equal to 2, greater than 2. Then you have 10 as well. So now you have the value at for 2 below and above, 10 below and above. So you have to use 2 and 10 both points to get the relationship and solution. Because we need 2, because there are 2 variables, you need 2 equations. So we'll start with 2 here. X equals 2. So 2 minus h will put here, 2 plus h will put here for LHL and RHL. You don't have to do anything here because it is already a constant 5. Yes, ax plus b in place of x, replace it by 2 plus h. So a 2 plus h plus b. Now apply the limit here. Limit h tends to 0, it will be 2a plus b. So you have first equation which you got is 2a plus b equals 5. This is your first equation. 2a plus b is 5. Now this second one, which is the point 10. So 10 minus h on the left hand side, 10 plus h on the right hand side, and 10 minus h will put it in ax plus b. So a 10 minus h in plus b. 10 plus h you cannot put anywhere because it is already a constant. 21, just keep it as 21. So apply the limit. It will be 10a, h is 0. So 10a plus b equals 21. This is your first equation. Second equation is 2a plus b equals 5. Two equations are there. Now just subtract these two equations. bb gets cancelled. 10a minus 2a is 8a. 21 minus 5 is 160. So 21 minus 5 is 16. A is going to be 16 by 8. That is going to be 2. So a is 2. Now put it here. So 2 into 2 plus b equals 5. B is equal to 5 minus 4. That is going to be 1. So b is 1 and a is equal to 2. Right? So this is continuous, and the point of check is x equals pi by 2. And see, x equals pi by 2, 3 is already given. So rather than actually going through the left hand limit and right hand limit, we can very well see that the left hand limit or the right hand limit, only one computation is necessary. But you have to show the examiner that you are doing LHL, RHL both. Because pi by 2 minus h on the left hand side, pi by 2 plus h on the right hand side. So we'll use this function x less than pi by 2, k cos x, I'm replacing it by pi by 2 minus h, divided by pi minus 2 into, in place of x, just put pi by 2 minus h. On the right hand side, well, it is not necessary, it is not required, but still you have to do. 3 tan 2 into pi by 2 plus h, and then we have 2 into pi by 2 plus h minus pi. This you have to do, okay? But what I'm saying is, we can just get the answer by finding out the left hand limit only. Because the left hand limit and right hand limit and the value of the function at x equals pi by 2, they will be same, because the question is already saying it is continuous. So k cos 90 minus theta is sin theta, just sin h. Now this is pi minus 2 into pi by 2 plus 2h. So this gets 2 gets cancelled, pi minus pi plus 2h, pi gets cancelled, you have 2h here. So sin h by h, you can directly apply the limit here. Sin theta by theta, limit theta tends to 0 is 1. So this is 1. I am applying the limit here. So sin theta by theta, sin h by h is going to be 1. So you get k by 2. Now this k by 2, the value of the function at pi by 2 is already given. It is 3. F pi by 2 is 3. So eventually k by 2 is equal to 3. So k gives you 3 into 2, 6. This is your final value. The function fx, you have x squared by a, you have a, 2b squared minus 4b by x squared. And what are the points? So let us draw a number line and see what these points are denoting. And what are the points of check we have to do, for what we have to find out LHL and RHL. So let us see here. Actually it's more of a quadratic equation problem rather than this continuity. You'll see just now. So this is 0, this is 1, and root 2 is 1.414. So I am just writing root 2 here. And then we have infinity. So now we have a point 1 and root 2. So you have 2 points here. So x equals 1 you have to check, x equals root 2 you have to check. So 1 minus h it is, 1 plus h it is, because LHL and RHL you have to do. Here root 2 minus h you will put, and root 2 plus h. Root 2 minus h and root 2 plus h. Right. So there will be some relationship. That relationship will finally give you the value of the a and b. Okay, when you go on the left of 1, you have to use x square by a. So 1 minus h square by a you have to write. 1 plus h, it is already a constant a. So h, just apply the limit, right? And RHL, you don't have to apply any limit. Here h will be 0, so 1 by a. This is a. This will remain as a. So 1 by a is equal to a basically. So you will get a square as 1. So a square is 1, so a will be plus minus 1. So you are getting two values of a. What I am trying to suggest is LHL is equal to RHL. So a is 1 by a square equals 1. So a will be equal to plus minus 1. A will be under root 1, and always when you take the square, it can be minus and plus because it is even power. Now coming to the right hand side. And when you go on the left of root 2, you have to use a. So don't worry about putting root 2 minus h. Now coming on the right, you have to put root 2 plus h in this 2b square minus 4b by x square. 2b square minus 4b by x square. So x will be replaced by root 2 plus h whole square. Now root 2 plus h is actually 0. So root 2 whole square plus h square plus 2 root 2 into h. I am just opening root 2 plus h whole square. So wherever h is there, just apply the limit. Root 2 whole square is 2 only. So 2b square minus 4b, you can take 2 common from here. 2 into b square minus 2b. Since we have a 2 in the denominator, you can cancel these 2 out. So it will be only b square minus 2b. 2 gets cancelled in the denominator. I am just taking 2 outside. It will be b square minus 2b. 2 gets cancelled. Now b square minus 2b. What is the relationship? LHL, RHL. So b square minus 2b is equal to a. So a will be plus 1, a will be minus 1. What I am trying to suggest here is b square minus 2b is equal to a is plus minus 1. So we will get two equations here. B square minus 2b equals 1, b square minus 2b equals minus 1. So a was plus minus 1. A1 will take one time, a equals minus 1 will take another time. Since already this b is b square minus 2b equals a. So b square minus 2b, this is equal to 1. And b square minus 2b equals negative 1. So b square minus 2b minus 1, you will not get a proper relationship here. But here you can get factor b square minus 2b plus 1. So we can use the Sridharacharya formula anytime. But b square minus 2b plus 1 can be easily solved. B square minus b plus 1. You can take b common, b minus 1, and minus 1 common, b minus 1. Minus 1, I am just changing it to minus 1. And b minus 1 inside. Okay. So you have b minus 1 into b minus 1. That is b equals 1. b equals 1 is your one result. Now when you have this b square minus 2b minus 1, as I said, this is mainly a quadratic equation solution. So assume it to be ax square plus bx plus c. B will be equal to minus b plus minus under root b square minus 4ac by 2a. You know what to use for a, b, c. So I'm just writing those values. And this is 2. So you get 2 plus minus under root 4, 8. 8. In place of 8, you can write 2 root 2. So just replace it by 2 plus minus under root 2 root 2 by 2. You can cancel 2. So 1 plus minus root 2 it will be. So one time it will be 1 plus root 2, one time it will be 1 minus root 2. So what do you see here? A is equal to 1, a equal to minus 1, b is equal to 1 plus minus root 2. Okay. So this is whole answer you have to write because these are the suitable values for a and b. Find the values of a and b so that the function fx is defined by fx is equal to, there are three functions given and they are continuous, means they become continuous from 0 to pi. That is, from 0 to pi there are certain points where the function changes. Pi by 4 and pi by 2. Now between 0 and pi, 0 is indicating 0, pi is indicating 180 degree. So we have 2 points in between 0 and pi by 4 and pi by 2. Now pi by 4 is corresponding to 45 degree, pi by 2 is corresponding to 90 degree. Okay. Now from 0 to pi by 4, the first one, x plus a root 2 sin x. Pi by 4 to pi by 2 will use 2x cot x plus b. And from pi by 2 to pi will use a cos 2x minus b sin x. For being continuous and differentiable, what happens? First of all, the continuity is left hand limit should be equal to right hand limit. So for your reference, I am just giving you the solution, and I'm going to tell you how it is done. But the answer is for your reference to right? The logic I am going to tell you. From 0 to pi by 2. So the point where the function changes or inversion takes place is pi by 4. So from to the left of pi by 4 and to the right of pi by 4, we need to find out. Similarly, at pi by 2 also there is a inversion of the function. So at pi by 2, we'll also check left hand limit and right hand limit. Let's see what happens. So we'll start with x equals pi by 4. Pi by 4 is essentially 45 degree only. And since it is being said that this becomes continuous, or we have to assume that it is continuous. And by assuming being continuous, we have to find out the value of a and b. So if you just move, you are just away before pi by 4, you can write pi by 4 minus h. Minus h, h is can be neglected. It is very small. It is all equal to 0, not equal to 0, but almost equal to 0. Similarly, pi by 2 plus h are a bit further than pi by 4. So we'll put first x equals pi by 4 and then pi by 4 minus h on the left hand side, and we'll replace x by pi by 4 plus h on the right hand side. Please remember, at pi by 4 minus h, you are behind pi by 4, so you have to use the first number function. Just a point ahead of pi by 4, you have to use 2x cot x plus b. Okay. So these two functions we have to use, one for left hand limit and one for right hand limit. And function number 1 is, as I said, x plus a root 2 sin x. Here we are going to put pi by 4 minus h. And then on the right hand side, right hand limit or right hand side, we will put x in 2x cot x plus b. So I am placing this pi by 4 minus h in the first function. So pi by 4 minus h plus a root 2 sin x. And in place of x, we are replacing it by pi by 4 minus h. So pi by 4 minus h it is. Minus h, you have a root 2 plus a root 2. And sine pi by 4 minus h. So we don't have any formula for sine pi by 2 minus pi by 4 minus h. So what to do here? The general idea or the general solution is, you have to open sine pi by 4 minus h. And this has to be done using sine a minus b formula. If you are aware of sine a minus b formula, you have to open it, then you have to solve it, and then show the examiner or your teacher that this is how we do it. And that is the way. So if you are aware of sine a minus b, put it here. You should be aware, actually the solution will be like that only. But what I am going to do is, I am going to apply the limit directly. Why? Because I can see in this particular equation or expression, if I apply limit h tends to 0, I am not getting any value unprecedented like 0 by 0, 0 by infinity, infinity by infinity, which is undefined. So all are defined. If you put h as 0, we'll get a value of this function which will be defined, not undefined. So just put h equals to 0. Pi by 4 plus a root 2 sine pi by 4 will come. Okay. Please remember, you have to do it like sine pi by 4 minus h. You have to open the formula, because that is the way. Now sine 45 degree, that is sine pi by 4 is 1 by root 2. So just replace it by 1 by root 2, 1 by root 2, 1 by root 2 cancel. You get pi by 4 plus a. This is your left hand limit. Now for the right hand limit, on the left hand side, you have done pi by 4 minus h. On the right hand limit, you have to add some very minute value, which is h. H tends to 0. H is very small, so it can be assumed to be 0. It is not 0 eventually. It's very small value. So we'll put it in 2x cot x plus b, the value of pi by 4 plus h, which is while I'm putting it while you watch. So this is 2 pi by 4 plus h cot pi by 4 plus h plus b. Now you have to use the formula of cot pi by 4 plus h, cot a plus b, or you can use 1 by tan a plus b. This is up to you. But remember, sin a minus b, tan a plus b formula or cot a plus b formula have to be used. This is the way this will be solved. If somebody tells you just put h equal to 0 and go ahead, it's wrong. Right? I am putting h equals to 0. Why? Because I know that I am not getting any value which I cannot comprehend, or which is not acceptable in mathematics. So what I am doing here is I am putting h is 0. So 2 into pi by 4 is pi by 2. Cot pi by 4 h I am replacing as 0. But you have to do it by cot a plus b. Please remember. So cot pi by 4 because tan pi by 4 is 1 by root 2. Cot pi by 4 will be equal to this is 1. Tan 45 degrees 1. Cot 45 degrees 1. So I am just replacing cot pi by 4 by 1. So pi by 2 plus b will come. Now left hand limit has to be equal to right hand limit as we discussed earlier. So I am equating pi by 4 plus a equals pi by 2 plus b. Now when we equate this, we get an equation. The equation is pi by 2 minus pi by 4, which is eventually be equal to pi by 4, is equal to a minus b. So this is a minus this will not be b minus it is going to be a minus b. Let me just place it. Okay, so pi by 4 equals a minus b. This is the first equation, and since we have discussed what exactly has to be done, so the same way you have to do it. The way we have done for pi by 4, you have to do it for pi by 2. So pi by 2 minus h in the left hand limit, pi by 2 plus on the right hand limit. For pi by 2 minus h, you have to use the second function. For pi by 2 plus h, you have to use the third function. Okay. So when you put pi by 2 minus h in the 2x cot x plus b, you will get the value as b. Please recheck it. And in the third function, you are going to put pi by 2 plus h, which will give you minus a minus b. Okay. So x equals pi by 2. For x equals pi by 2, the left hand limit and right hand limit has come as b and minus a minus b, which I am equating. Actually, it is a minus b, rather minus a minus b and b. So 2b equals minus a. It will be a equals minus 2b. So a equals minus 2b here. Now put it here in pi by 4 equals a minus b. This already we have seen. So in place of a, I am replacing it by minus 2b. Minus 2b minus b is minus 3b. So pi by 4 equals minus 3b. b will be equal to 4 divided by 4. Pi divided by 4 multiplied by minus 3. So minus 4 pi by 12 it will be. So b is equal to minus pi by 12 and a is equal to minus 2b. So just multiply minus pi by 12 by minus 2. So minus 2 into minus pi by 12 is going to give you 6 pi by 6. So this is how the value will be computed, a and b. The function fx is defined as follows. So it is if f is continuous on 0 to 8, find the value of a and b. There is no sine cos, but this question is exactly similar to what we have done just now. Okay, so to pre-anticipate what is going to happen is to make a number line. You'll start with 0, 8. These are the endpoints, or you can say this is the domain or boundary, whatever way you call it. Now 2 is in between, where the function inversion take place. 4 is that value where the function inversion take place. So the graph will, the graphical view also, you can assume that there will be some change. So that change, that point of change need to be continuous. And when it is being said that it is continuous, so you are assuming that it is continuous. So you are going to check at x equals 2 and x equals 4. So at x equals 2, we will find out the left hand limit and right hand limit. So on the left hand side, we will put 2 minus h. On the right hand side, we will put 2 plus h. So 2 minus h, we will use the function number 1, which is x square plus ax plus b. So we will replace this 2 minus h in place of x in x square plus ax plus b. And we will replace 2 plus h in 3x plus 2. So these are the function number I am telling you, where you have to use the function. So 0, 2 function is first one, 2, 4 the function is 3x plus 2, 4, 8 the function will be 2ax plus 5b. I hope you got the idea. Now coming to left hand limit, we are going to use x square plus ax plus b, but we have to put x equals 2 minus h. So this is the first function we are going to use, and we'll replace x by 2 minus h on the left hand side. So 2 minus h whole square plus a into 2 minus h here and plus b. Now placing 2 plus h, we'll place it at 3x plus 2. So 3 into 2 plus h plus 2. Now the answer which I am showing is for your reference, right? Because I am going to tell you the logic, but you need to understand how you are going to write it. Because solving a question is just not what I am doing. It's just giving you an idea. I'm actually training you. But as a student, you have to write all this. At x equals 2, we have is continuous at x equals 2, equals 4. This has to, everything has to be written properly. That is the reference I am giving you. Okay, coming back to the solution. I'm not finding any, if I put h equals 0, I'll get some unprecedented value. So I can just put h equals 0 here. So 2 minus h whole square. What you have to do is you have to open it 2 minus h whole square, 4 plus h square minus 4h. I am not doing it because I have some experience. I know that there is no difference in 2 minus h whole square opening and without opening if you put h equals 0. But for you have to open this, right? The previous question we saw sin a minus b has to be opened, then h tends to 0 has to be put. So h is 0, I am putting 2 square is 4 plus 2, h is 0, so for 2a plus b. Again here, so 3 to 6 plus 3h. This is how you have to do it. I am replacing h by 0, but you have to do it by 3 into 2 plus h, 6 plus 3h. So h tends to 0, you get 6 plus 2, which is going to be 8. So left hand limit is 8, right hand limit is, because LHL has to be equal to RHS if f is continuous at this point, 2, which we are checking. So for plus 2a plus b has to be equal to 6 plus 2, that is 8. So 2a plus b should be equal to 8 minus 4, that is 4. So this is the first equation. This is the first linear equation. And the second linear equation will get by x equals 4. So now the second point where the function actually changes is x equals 4. So left hand limit will put 4 minus h. On right hand limit will put 4 plus h. But the functions will change. So 4 minus h on the left hand limit of 4, we are going to take 3x plus 2. I am replacing x by 4 minus h. And x equals 4 plus h, I am replacing 2ax plus 5b, the x value with 4 plus h, because we are on the right hand side of 4. And between 4 and 8, we have to use the function 2ax plus 5b. Okay. So 2a in the place of x, I am putting 4 plus h plus 5b. Now you can just put h equals 0, but let me guide you. You have to do like 4 to the 12 minus 3h. Then this is how you have to do. Just don't put h equals 0 as I am putting. You have to multiply it, open it, show every term and then do it. Okay. So I am putting h equals 0 on both the sides. So this is limit h tends to 0. Let's apply it on both the sides. It is going to be 3h will be 0, 12 plus 2 is 14. Here 8a plus 5 by 2h is going to be 0. So for 8a plus 5b equals 14. Now this is the first equation, second equation. First equation was 2a plus b equals 4. Now in order to solve this, let me multiply the first equation by 4. Why? Because we'll get 8a. So 8a plus 4b equals 16. I multiply first equation by 4. And just subtract these two equations. 8a gets cancelled. 5b minus 4b is b. 14 minus 16 is a negative 2. So b is equal to negative 2. Okay, put it here. This is just a linear equation. You know, the a and b will be determined by this only. So 2a plus b is minus 2 equals 4. 2 equals 4 plus 2, that is going to be 6. A is equal to 3, B is equal to minus 2. So these are the values for this to be continuous. If fx is tan pi by 4 minus x cot 2x, for x not equal to pi by 4, it's being very clear that x cannot take value as pi by 4, because tan pi by 4 minus pi by 4 is tan 0. Okay, and cot 2x is 2 into pi by 4 is what? It's pi by 2. So cot pi by 2, which is eventually 1 by 10 pi by 2. 10 pi by 2, 10 0 by 10 pi by 2, or 1 by 10 pi by 2 is not a great value. I mean, we cannot comprehend that value. It is unprecedented. So we don't want any value to be 0 by 0, 0 by infinity, infinity by infinity, like that. That is how we do it. Now from 0 to pi by 2, we want it to be continuous. The question is saying that. But pi by 4 is in between. So there is a point where some function change is there or some discontinuity is there. So the question is asking, we have discontinuity at pi by 4, or we may have continuity at pi by 4. Now please tell us what will be the value f pi by 4 will be, so that this function is continuous right from 0 to pi by 4. That is at the point pi by 4, f pi by 4 we have to tell. And how to tell that? Because being continuous means left hand limit has to be equal to right hand limit. Being differentiable means left hand limit has to be equal to right hand limit, equal to the value of the function at that point, that is which here we are talking about pi by 4, because that is the point of contention. That is the point of concern. So what we will do is, that point of concern, please remember tan theta, cot theta, they both are continuous at from 0 to pi by 2. And 0 to pi by 2, where 0 and pi by 2 are not included. This 0 to pi by 2, for tan and cot, they are continuous, right? Because it is p by q form. One function p is continuous, q is continuous. When p and q are both continuous, you can say that p by q is also continuous. Okay, this is what we have learned. But the problem is pi by 4, because at pi by 4, we are not going to get the values we want, or which is not acceptable in mathematics. So we have to check the function at x equals pi by 4. So we'll find out the left hand limit and the right hand limit. Pi by 4 just behind pi by 4 and in front of pi by 4. Those values we have to take. So it can be very small value h. We can add and subtract. So left hand limit pi by 4 minus h. X equals pi by 4 plus h for the right hand limit. So the left hand limit has to be equal to right hand limit, and that has to be equal to the value of the function at pi by 4. So if the LHL and RHL are coming equal, that has to be equal to f pi by 4, which is the question asking. Question is asking what value to be assigned to f pi by 4, so that this function becomes continuous in the interval 0 and pi by 2. So that is why left hand limit and right hand limit we have to compute, and probably they are going to come equal, and that will equate to f pi by 4. Right? Okay. So pi by 4 minus h we have. This is tan pi by 4 minus x. In place of x, let us replace by pi by 4 minus h, which is eventually going to be equal to pi by 4 plus h. In the denominator, we have cot 2. In place of x, we are placing pi by 4 minus h. So cot pi by 2 minus 2h, and cot pi by 2 minus 2h, and cot 90 minus theta is tan theta. But it is in negative. So in the numerator, pi by 4 cancels tan h. So this denominator will be cot 90 minus theta is tan theta. So tan 2h. Okay. Now this cot has become 10, and it will not be negative, because if you remember, add sugar to coffee, pi by 2 minus everything will be positive only. So tan theta by theta is 1 for limit. So I am making tan h and tan 2h such that we get this tan theta by theta form. So we multiplied numerator denominator by h in the numerator, denominator of the denominator by 2h. Okay. So tan h by h is 1, tan 2h by 2h is 1 when we apply a limit h tends to 0. So h by 2h only will remain, you'll get 1 by 2. Oh, coming to the right hand limit, similarly we'll place pi by 4 plus h in this function. So tan pi by 4 plus pi by 4, and since pi by 4 plus h is there, but there is negative also. So we have to replace this both sign by negative, pi by 4 minus pi by 4 minus h. So both are negative here. And in the denominator again we are going to replace this x by pi by 4 plus h. So what do you get? Cot 2 into pi by 4 plus h. So 2 into pi by 2 is pi by 2 plus 2h. So cot 90 plus theta. Here it is going to come as negative. Cot 90 plus theta is minus tan theta. So tan numerator you will get 10 minus h. And denominator you have cot 90 plus theta, which is going to be minus tan 2h. And tan minus theta is equal to minus tan theta, as in sin minus theta is minus sin theta. So numerator will be minus tan theta, denominator was already minus tan 2h. Remove this minus sign. So tan h by tan 2h it will be. So you have limit theta tends to 0, tan theta by theta is 1. So we'll do it the same way, tan h by h into h, and tan 2h by 2h and 2h by multiplying numerator denominator. This way we have to introduce ourselves. Applying tan h tends to 0, this is going to be 1, this is going to be 1, h gets cancelled, you get 1 by 2. So LHL and RHL both are 1 by 2. Okay. So this LHL and RHL, when it becomes 1 by 2, the question is asking what value of function f pi by 4 should be so that this function is continuous in this interval. So that has to be equal to LHL and RHL, which is equal to half. So f pi by 4 has to be half so that the function is continuous everywhere. This is the answer. Okay, from 0 to pi, this will be continuous. Discuss the continuity of the function fx. This is, there are two functions actually, and when x is less than 2, that is on the left hand side, the function to be employed or suggested is 2x minus 1, and on the right hand side, that is x equal to or greater than 2, the function is 3x by 2. So we have to discuss this continuity. Okay. So there is a point where some inversion is there. That is, the function is inverting, so function is changing. So that particular point is continuous or not. So this 2x minus 1, it is a polynomial function. And polynomial function, we know already about it, that it is continuous everywhere. Coming to on the right hand side, that is 3x by 2. Now this is p by q form. P is 3x. So since p, this is also a polynomial function, and 2, which is a constant number, if this is also constant, is also a continuity it follows. So the function 3x and 2 are continuous because polynomial constant function, right? So the quotient function, that is the p by q form, this will also be continuous when x is greater than 2. So we have to consider, we have to see the point of contention, which is x equals 2, where actually these two functions meet or change. So we will just go a step back and step forward, that is 2 minus h, 2 plus h. H is very small, and we call it as the left hand limit and right hand limit. Okay. So left hand limit and right hand limit. What are the values? Because on the left hand side, we have to use another function. Excuse me. On right hand side, we will use another function. So x is 2 minus h, x equals 2 plus h. So first function is 2x minus 1. So x is 2 minus h we will put here. So it will be 2 into 2, 4 minus 2h minus 1. Apply the limit. H tends to 0. So it will be 4 minus 1, that is 3. Right hand side, 2 plus h is there. And we are going to put it in 3x divided by 2. So 3 multiplied by 2 plus h divided by 2. This is going to be 6 plus 3h and divided by 2. So apply the limit here. Limit h tends to 0. 3h is 0, 6 by 2 is 3. So what it suggests is the left hand limit and the right hand limit, they are equal. So continuity is there. We have to add one more thing here, that the value of the function at 2. What is the value of the function at 2? So this f2 is going to be 3 multiplied by 2 divided by 2. That is, put the value of x equals 2 in 3x by 2. That is the value of the function at x equals 2. So it is going to be 3 again. So left hand limit, right hand limit and the value of the function at 2, they are equal. So fx is continuous at x equals 2. Discuss the continuity of function fx, which is equal to sine of mod x. This is a modulus function inside. So this sine mod x, there are two things here. Because the modulus of x is by itself a function. Modulus of x, we already talked about the continuity, differentiability, etc. of this mod x. And the sine theta, sine x, this is another function. So there are two functions here. That is, mod x is a function which is inside sine x. In place of x, we have put in mod x. So hx, if you assume it to be modulus of x, this hx, and assume this mod x to be theta. So sine theta is by itself a function. So hx, just assume that mod x is hx and gx is sine x. So in place of x, there is mod x. So sine of x is sine of mod x basically. So sine of mod x, you can represent it, that is hx is placed inside x. So g of hx it is. So gx is sine, this mod x is what? This is hx. If we take it as a function of as hx. So gx is sine of hx. So what does it mean? That means in place of x, you might have put hx, which is actually a function. So g of hx is sine of hx. This is the only way when the sine hx will come. I am just trying to tell you that there are two functions, combination of two functions, or you can say operation of two functions, which is g operation hx, because g operation h of x is g of hx. G of hx. So this is nothing but operation. You might have heard about GAW, fog, like that. So you can assume this one is g, one is f. Here I have taken it as h. You can always take it as f. So this is an operation, GAW operation, fog operation. So now we know the continuity, that for a GAW or a fog, for two functions, if they are continuous, then the fog and GAW function will also be continuous. That is, the real number is a big boundary or the values. So if you take some C point, say, in this domain, the domain of real numbers, then if f is continuous at C, what does it mean? The value of the function at C should be fc. The value of the function, that is sine mod x, if you put sine mod c, it should be equal to fc, that is sine of mod c, which is understood also. Okay. So let me tell you again about this gx and hx. Gx is if you take it as sine x, hx if you take it as mod x. So this function which is given to us is nothing but g operation h, GAW h. So g operation h of x, it is g of hx is what? G of hx means the function of g, the value of x has to be replaced by hx, which is mod x here. So g of mod x, and what is the function gx, which is sine x. So this mod x I have to put in gx, so sine mod x, right? This sine mod x is what? Fx. So when we started with the value of the function at x tends to c, we have got fx. We have got fc if you replace it by c. So this is the operation one. Okay. So when two functions are there, they are individually continuous. The operation of these two functions, which is GOF, FOG, or what kind of operation, division, multiplication, all these will give you the continuity. So this is continuous. Sin mod x is continuous for all values of real number. Okay, mod x, sin x are individually, they are individually continuous. So the operation GOH, HX, we proved it to be G of operation HX. Okay, so when we proved that this is actually an operation and there are two different functions, this is whole is continuous. Prove that fx equals sin x by x when x is less than 0. This is x is less than 0. We are going to use sin x by x. X is greater than or equal to 0. We'll take it as x plus 1. Okay. So this is continuous everywhere. The first thing is individual functions we have to see. First is sin x. And it is divided by x. So this is p by q form, quotient function it is. Now we have just discussed that sin x is continuous everywhere. Sin x, this is divided by x, which is an identity function. So x is an identity function, sin x is a trigonometric function. They both are individually continuous everywhere. So the division, that is the quotient function sin x by x, this also is continuous at each x. Okay. X plus 1 is again a polynomial function. So this is also continuous everywhere. We have to see the point of contention is x equals 0. So we have to go a step back, step forward, which is the left hand limit and right hand limit. So x is 0, so we'll just subtract some value 0 minus h. We'll add some value which is h, which is 0 plus h on the right hand side. So left hand side and right hand side we are trying to find out. X will be replaced by 0 minus h in left hand limit. X will be replaced by 0 plus h on the right hand limit. But when we go to the left, the function employed will be sin x by x. On the left hand side, it will be sin 0 minus h by 0 minus h. And please assume that I am putting that limit h tends to 0. See, why I actually show you the solution, because I can have solution in my hand and I can always tell you how to solve it. But the thing of the reason of showing you the solution is that how you are going to write it. Logic I am going to tell you, reasoning I am going to tell you, but the main thing is what you have to write, like given, let us consider, also, and the limit properly writing, brackets properly using. Okay. Now coming to the right hand side, right hand limit, I am placing 0 plus h in x plus 1. So the left hand becomes 0 sin minus h by minus h. You know that sin minus theta is a minus sin theta. So this is going to be minus sin h divided by minus h, negative negative cancel, sin theta by theta, limit theta tends to 0, or sin h by h, limit theta tends to 0 or h tends to 0 is going to be 1. This we know. Now here h is 0, 0 plus 1 is 1. So both ways, that is left hand limit, right hand limit, the values are same, which is equal to 1. Right? So when left hand limit and right hand limit are equal, the function is continuous at x equals 0. Now what is the value of the function at 0? Since we have x greater than or equal to 0, we have to use this function, because for equality, when x is equal to 0, we have to use x plus 1. So I am replacing this x by 0. So 0 plus 1 is 1. So left hand limit, right hand limit, along with the value of the function at x equals 0 is 1. So we can say that fx is continuous everywhere. Right? It is continuous everywhere. Show that the function gx equals x minus, and this is GIF, greatest integer function. So I'll call it as GIF. So this is continuous at all integral points. We have to show it is discontinuous. this you can say square bracket of x is GIF, greatest integer function. Now there is a property of greatest integer function. First of all, integral points 0, 1, 2, minus 1, minus 2, because the question is talking about the integral points, not the real number. Only 1, 2, 3 or minus 1, minus 2, minus 3, right? There is no other function, there is no other value being put. Now greatest integer function, if we just take it as say n, and let me explain it with an example that will be more better. Because the greatest integer function, for example, you take 2 and 3, these are two integers, and there will be certain values inside, actually infinite values. So we have 2.1, 2.2, 2.9, 2.96, 2.9996, like this. There are indefinite value which can be between 2 and 3. But for 2.2, the greatest integer function GIF will be 2. For 2.9, it is going to be 2. So greatest integer function is actually a floor function, you can call. You'll always take the lower integer until it becomes this next integer. You got the idea? So here we have gx equals x minus of GIF. And this greatest integer function I explained you. First of all, this function is defined in this integral point, because you're not getting any 0 by 0, infinite by infinite, 0 by infinite, or infinite by 0, any kind of this operation or the formulation you didn't get. That means it is defined. So if you take say 1 minus greatest integer function, or GIF of 1 is 1 only. So 1 minus 1 is 0. Okay. Now we have to, this value of the function at some n we have already found out. It is 0. But for n equals z, or n belonging to z integers, we'll take the left hand limit and right hand limit. And in the left hand limit and right hand limit, we would like to find out whether they are equal or not, or whether they are equal to 0 or not. Because gx at the value of n proper or x, we have just found out. Gn equals n minus this GIF of n. Okay, the left hand limit and right hand limit. So first value, as I said, if you don't change the value, or the value of the function at some certain integral value, it is going to be 0, because I showed you 1 minus 1 0, n minus n 0. Now when coming to the left hand side, we have to subtract some h from n, and on the right hand side we have to add some h to n. So the left hand limit and right hand limit, LH and RHL. See, g in place of x, we are putting g n minus h. So we can call it as x tends to n plus, or x tends to h tends to 0, both ways. So g n minus h, in place of x we have to replace n minus h, because we are taking the left hand limit. So we have subtracted some h from n. So both time you are going to replace n minus h, n minus h. Now I told you that when you have something less than n, you have to go to the floor of that value. Say for example n minus h, it would have been 3. So when you subtract some 0.01 value, it will be 2 point something, and you have to take 2. That is n minus h, you have to take value as n minus 1, the floor. Okay. Now apply the limit, n minus h minus n minus 1. So h tends to 0, this is going to be 0, n minus n plus 1 it will be, and n gets cancelled, you have 1 here. The value is 1. Right hand limit, let us come on to the right hand limit. What is the right hand limit? X equals n plus h. In place of x, replace it by n plus h. So you have limit x tends to n plus, you can write, limit h tends to 0, you can write, it's up to you. Okay. So this is n minus, or x minus GIF of x. I'll replace x by n plus h. So n plus h minus n plus h. Now you are moving forward from n. For example, it is 3. So you are adding something to 3. So it will be say 3.001 or 3.1 or something. But whenever you get this value, you have to take the floor. So you have to take 3. So for n plus h, you will always take n only. For n minus h, we have taken n minus 1. For n plus h, you will always take n, which is the floor of value. So n plus h minus n it will be, and n gets cancelled, h is 0. So when you apply a limit h tends to 0, it is going to be 0. The left hand limit is 1, right hand limit is 0. The value of the function at some value n is going to be 0. So these three values doesn't match, two values match. But before going to the value of the function at n, the left hand limit and right hand limit by itself they are not equal. And when they are not equal, you can say that this function is discontinuous. Continuity and discontinuity, the basic step is LHS has to be equal to RHS, which is not the case here. Discuss the continuity of the following functions. Now here if you see, we have sin x plus cos x, sin x minus cos x, and sin x cos x. In all of these parts, sin x and cos x, there are two different functions. And for example, if you take one function is f, one function is g, then this is nothing but the operation between the functions. That is, if you have function g, the other function as h, g in this case is sin x, h in this case is cos x. So what we are doing is, we are adding two functions, that is sin x plus cos x, which is g plus h. Then we have g minus h, so sin x minus cos x. And then sin x multiplied by cos x, that is you are multiplying. So sin x and cos x by themselves they are continuous. But we are g plus h, g minus and g into h doing these operations on these two. So how does this cos x and sin x are continuous? Because if sin x and cos x are continuous, then the operation should be continuous. Okay. So the function of two functions, the operations are continuous, but are these functions by themselves continuous? That we have to see. So first we have to tell or show that sin x is continuous. So this gx is our sin x, we assume it to be sin x. And since sin x is defined, or you can say it's defined for every real number. So let us take any value c or k, whichever you want. So at this point c, let's check whether it is continuous or not. So what we do here is, we are taking c as constant and you just say that x is approaching c, or the value of x at c is what? So in this sin x and cos x, what you do is you replace x by c plus h. So when you put the value of c in this function, it should be sin c. That is, when x is approaching c, you should get sin c. I am just saying that x is not equal to c, but x is almost equal to c. So gc should be equal to sin c. If this is possible, or this can be shown, then we can say that this function is continuous, because we are going to check for c plus h or c minus h, left hand side or right hand side. So it's up to you. You want to put c plus h, it's up to you. C minus h, it's up to you. I am replacing x by c plus h. Okay, so x minus c is h. When x is tending to c, what does it mean? When x and c are same, x minus x or c minus c is 0. So h tends to 0. So when x is tending to c, or x is similar to c, and h tends to 0, then this gx, when we apply this limit, that this gx function, when the x is actually approaching c, and as I said, x we are replacing by c plus h. C can be any constant, but x is that value which is to be defined for every point in that domain, which is the real number. So we have limit x tends to c, sine, and x, but as I said, x is c plus h or c minus h, whatever you want to put. I am replacing x by c plus h. So this sine c plus h, and sine c plus h is, because we have to open it using sine a plus b. So sine a cos b plus cos a sine b. This is sine a plus b. Now limit is already there. And this limit is x tends to c, but when x tends to c, so h tends to 0. So both sides we will apply h tends to 0. So when x tends to c, h tends to 0. Okay. Now this is sin c cos h. So sin c is constant, take it outside, limit h tends to 0, cos h plus cos c I am taking constant, then limit h tends to 0, it is sin h. Now cos 0 is 1, so sin c into 1 is sin c. Sin 0 is 0, so this whole term will be 0. So you get sin c. So limit when we have x tends to c, gx is sin c, and in beginning I told you, if we can get gc as sin c, that is, it is continuous. Clear? So now this is done, sin x. Same thing we have to do for cos x. And this, you don't have to prove sin x plus cos x is continuous or not. Sin x individually, cos x individually, if they are shown to be continuous, then the operation, that is plus minus multiplication, they will always be continuous, which we have seen in the theory or discussion also. So let me excuse me, let me change this cos x we are doing. So this same thing, what we applied in sin x, same thing we'll do. That is, there is a number line and this is c or real number, any c. So x is approaching c. So we can always put this c plus h or c minus h. That is, when x is tending to c or x just becomes equal to c, the h will be tending to 0 because x equals c plus h or c minus h, whichever way you take. So what we are trying to do here is limit x tends to c, the hx function which we have taken as cos x, when we replace x by c, so hc will be what? It will be cos c. So let us see whether it comes cos c or not. So replace x by c plus h or c minus h, whichever you want. I am replacing x by c plus h. So this will be limit x tends to c, cos x, and in place of x what we are going to put? C plus h. So limit x tends to c, and when x is tending to c, that means h is tending to 0, because x minus c, x is equal to c or c is equal to x, h is going to be 0. So limit h tends to 0, cos x, in place of x I am replacing it by c plus h. So this is cos a cos b minus sin a sin b. Cos a plus b formula is cos a cos b minus sin a sin b. Now I'll apply the limits individually to both the terms. So both we are applying. Okay. So this is cos c I am taking outside. Limit h tends to 0. It is cos h. And then we have minus. Again take the constant sin c outside. Limit h tends to 0. And this is going to be sin c, limit h tends to 0, sin h. Okay. Now cos h tends to 0, so cos 0 is what? It's 1. Sin 0 is 0, so whole term will be 0. Cos c it is. So this cos c, if we can get it, I told you earlier, limit x tends to c hx, which is our cos x. If it equals to cos c, if we apply hc, then we say it is continuous. So sin is continuous, cos is continuous, so sin x plus cos x will be continuous. Sin x minus cos x will be continuous. Likewise, sin x into cos x will be continuous. Show that the function fx equals cos x square is a continuous function. So this cos theta, now theta is x square. So cos x or cos theta or cos whichever is continuous, we have just seen in our question. And this theta which we are representing by x square is a polynomial function. This is already continuous. What I am trying to suggest here is cos x square is a combination of two functions. Cos theta or cos x or cos whichever value is fx. Theta is x square, which is gx. So cos x square is nothing but function f of gx. That is, when you put this gx inside f in place of x for fx, then you get this cos x square. So f of gx is nothing but f operation gx. And we know when we have f as a separate function, g as a separate function, then the operation of f or g will be continuous if f and g are continuous by themselves individually. Okay? So cos x we have just seen in the question. There are multiple questions coming in the later part where I'll say that cos already we have done. Just now we have done in the previous question. So this is the same thing you have to do. I'll just show you again, just to revisit. Okay, I assume that this cos x is done. Now we have to come for this x square. But we know already that this x square is a polynomial function, it will be continuous. But it's not like that, you have to prove it. So this sin x cos x is we have already seen. X square is continuous. Because when x square is continuous, when cos x is continuous, then cos x square will be continuous. So you have to take them separately. So take any number line, because it is defined hx equals x square is defined for every real number. So let us take k or any c. We have already taken c, so let us take k. So hx is x square, so hk will be k square. So when x is tending to k, that is x is approaching k, limit x tends to k, so this x square, what do you get? This is going to be k plus h. You can just replace it by k plus h. Then also same thing will come. X is, if you replace by k plus h, it will be k square plus h square plus 2 into k into h. Now apply limit h tends to 0. X tends to c or x, so h tends to 0. Right? X is c plus h, which we just saw. It can be c, it can be k. I am using them interchangeably. So h square and 2kh will be 0, so it will be k square only. So let us apply limit h tends to 0 when x is tending to k. So c plus h or c plus h in place of x I am replacing. So it is going to be k square only. So basically the idea is, take any point, say that x is approaching k and the function should come as the value of the function at that particular value. So fk will be k square. So this is continuous. Cos x we already done. So cos x square will also be a continuous function because basically it is an operation. Now this question fx equals mod of cos x. This is a continuous function. So we have fx, which is, there is one function which is modulus function. It can have anything inside. Just imagine you have just a modulus function. We have another function which is say called as hx, and that is cos x. And what is gx? Mod of hx. Mod of hx. So mod of hx is what? Mod of cos x. So ultimately what you have placed inside x? You have placed hx inside x. So basically it is g of hx which is giving you this mod of cos x. So g of hx is what? Gof or gotch x. It is operation only. So one function is modulus of x, one function is cos x. When we apply them, there is a simple operation which is g operation of h. So this is just an operation of two functions. So if we are able to show that both the functions, which is one is modulus function, one is cos function, if they both are continuous, then the modulus of cos x will also be a continuous function. So this cos x we have already done. So I'm not going to repeat it again. It will just be a repetition. But mod x we will just see here. So cos x already seen. You can have a visit here. Cos x we already shown, because we have to show in this question also that cos x by itself is continuous. Then only the operation will be, the operation with the modulus will be of continuous function. So this operation you have to show, mod x you have to show, and cos x by itself you have to show. I am not showing the cos x, I am just showing you the modulus of x. So modulus of x when x is greater than 0. Modulus of x will be negative x when x is less than 0. That is, on the negative number line it will be negative x, it will be positive number line, it will be positive x. So when you take a number line, you can be taking any value c. This c or k, it can be less than 0, it can be greater than 0, it can be equal to 0. So the constant you have taken can be less than 0, can be greater than 0, can be equal to 0. All the cases you have to take, because you are showing mod x is continuous, right? So what c is there when this x is approaching this c, because eventually you are talking about x. You take any constant c or k or whichever. Ultimately you have to talk about x, because here x is approaching c. So gx is equal to mod x, which is what we have presumed. So when you have limit x tends to c, that is x is approaching c, or x will be equal to c. And when you apply this on gx, it should be gc. Okay. So gc is what? When you put this gc, or you can say x is less than 0, it is going to be negative x. So gc is nothing but what? It is modulus of x, here modulus of c. And since c is less than 0, it is going to be minus c. So now you replace this gh, that is, you have to put this gc was minus c. And gx is what? Modulus x. Modulus x, when you are saying it is less than 0, because x is approaching c and c is less than 0. So x is less than 0. It is going to be negative x. But we are talking about c, not x. So it is going to be minus c. Okay. So gx, when you apply limit x tends to c, it is going to be minus c actually. Minus c is equal to minus x. So minus c in both the cases when it is less than 0. So when both are equal, that is for c less than 0, it is justified. When you have greater than 0, when c is greater than 0, what you do? Gx is what? It is modulus of x. When you apply this limit x tends to c, that x is approaching c. So you are talking about modulus of x, which is modulus of c. Modulus of x or modulus of c, or when c is greater than 0, it is going to be x or c. And what is gc? It is modulus of c. C is greater than 0, so it is going to be c only. So in both the cases, when x approaching c, it is c, and gc by itself, the value of the function at c is going to be c. Two are justified now. Now third one, c is equal to 0. Now c equals to 0, we have to go left and right. That is 0 minus h and 0 plus h, that is left hand limit and right hand limit, both you have to take. 0 minus h is 0 plus h. So 0 minus h is minus h, 0 plus h is mod h. Okay. So when you take the limit h tends to 0, limit h tends to 0 here, in both the cases you will get 0 only, because minus 0 is actually not defined, but mod of anything negative will be positive only, because mod of minus x is nothing but minus of minus x. I showed you already, mod of x less than 0 is minus of minus x. So both the cases you get 0. So left hand limit equal to right hand limit. Okay. So here all the three cases of mod x we have taken for any c, and we have showed that this modulus of x is continuous. Cos x you have to show by yourself. Okay. I'm just not doing it again. Find all the points of discontinuity of f defined by fx equals modulus of x minus modulus of x plus 1. Now this modulus is a different function. X is a different function. X is a polynomial function of 1 degree. So this is a combination of two functions. You can say this is the operation of two functions. So x is another function, mod x is another function. Similarly, x plus 1 is a polynomial. When it is inside a modulus function is another function, right? So hx, you can call it as mod x as hx, and mod x plus 1 is gx. So basically you are doing hx minus gx. Two functions subtracted. So we have to find all the discontinuity points, if at all they exist, in this expression or in this fx or function, which is a combination of multiple functions as I just indicated, right? So the best way is to take this x when this x is 0, x is 0 when it is 0, because the points of discontinuity have to be found out. When is x plus 1 equals 0? It is going to be 0 when x is equal to minus 1. So these are the 2 points where we have to check the discontinuity, 0 and negative 1. So the first step is first make a number line. This will make the things easier for you. So what are the different points as I just suggested? It's negative 1 and 0. So minus 1 and 0. So first we'll do is what? We will take the different domains. So fx is mod x minus mod x plus 1. First we will take this domain, that is minus infinity to negative 1. Or you can say that x is less than minus 1. So when x is less than negative 1, of course mod x is going to be negative. What is mod x? Mod x is simply x when x is greater than 0 and negative x when x is less than 0. Right? Basically it is x greater than or equal to 0, then it is x. So when we are talking about negative 1 and below that, of course mod x will be negative x. And this mod x plus 1 will also be, because you are going on the left of negative 1. For example, just put x as minus 2. What is minus 2 plus 1? It is negative 1. And what is the modulus of negative 1? Because it is negative value. As I said, the x value is negative, which is x is less than minus 1 in this case. So you'll get a negative of this modulus function. That is, the things will come out as negative. So you have to write minus x plus 1. So minus is already outside, but I am talking about when you remove this modulus sign, it will be negative of x plus 1. So just open this, it will be 1. Minus x cancelled. Now the second domain is this negative 1 to 0. So we'll include this negative 1. Right? So x is greater than minus 1 and it is less than 0. So we are talking about this domain. X is less than minus 1, we have already taken. But when we are taking minus 1 and 0, we have to include minus 1 because we have not included minus 1 when x is less than minus 1. So what is in between minus 1 and 0? Of course, x is less than 0, so it will be negative. But this x plus 1 will not be 0 because x plus 1 will be 0 only below minus 1, not below 0. From minus 1 to 0, it will be positive x plus 1. So modulus, when you open, x will be negative x, but x plus 1 will be positive x plus 1. So minus x minus x minus 1, you can just write it as minus 2x minus 1. So we have taken two domains now, two boundary values or inside what the function is behaving. Now the third one is greater than 0. So x is greater than or equal to 0. You have to include 0 because we haven't included 0 in the previous one. So x plus 1, of course, when it is positive in minus 1 to 0, it will be positive in x plus 1. And x is always positive when you go beyond 0 or right hand side of the 0. So what do you get? Negative 1. So what do you get? We are going to use this. Please remember, I am going to use it. So you just keep this in mind. So we can write the whole of the function like this, that if x is less than minus 1, what do you get? You get a 1. When you have x between negative 1 and 0, that is x is between inclusive of minus 1 and non-inclusive of 0, you're going to get minus 2x minus 1. When x is greater than 0, you will get x greater than or equal to 0, you will get minus 1. Okay, this is done. Now this is step 1 over. Step 2 is we have to check for 0 and minus 1 because the question is asking all about the points of discontinuity here. So we'll do minus 1, we'll do 0. Okay. So second step, you can check 0 first or you can check minus 1 first. So it's up to you. So x equals 0, x equals to minus 1, where the equation is going to get some discontinuity. So let us check at x equals minus 1. So x is minus 1. So what you can do is you can I'll tell you two methods. First, step 2 method is by -1 minus h and -1 plus h, which is left hand limit, and right hand limit we have already been doing. But you can use this fx function of the step 1 we have already found, right? But we are not using. I'll just tell you that in the step 3. So step 2 is I'm using the trivial method, -1 minus h, -1 plus h. I'm replacing mod x plus 1, the x with -1 minus h in this case. So it will be, you can take minus common, -1 plus h. Here you can cancel these two, minus h. So minus of something is going to be positive and it comes out of the modulus. Minus of something, it comes out, it will be positive. So h gets cancelled, you will get a 1. But you see this, in step 1 we have already found that it is already 1, fx is 1 for the first case. Now we are doing the trivial method for the step 2, right hand limit, -1 plus h. Just replace x by -1 plus h, and whatever you get, you can just cancel these. So I am applying this limit h tends to 0. This is going to be 0, so this term is cancelled. -1 plus h, you can just write it as -1. You can take minus common and you can get 1, and 1 minus h. So modulus of minus will be positive when you come outside. So 1 minus h, it will be, apply this h equals 0, you will get a 1. So this is 1, this is 1. And you can always do using the function of step 1 function, that is -2x minus 1. That I'll do in this step 3. So what is the value of function at -1? Just put x as -1. What do you get? This value. I'm just replacing x by -1. The value of the function at -1. So one time you get 1, one time you get 1, third time you also get 1. Left hand limit, right hand limit, and also the function value at -1. All the values are 1, so this f is continuous at x equals -1. Now the step 3 is check it at 0. So I'm not going to use the trivial method, left hand limit, right hand limit. You can always use that. But we are going to use the step 1 function which we have devised. So I'm just saying 0 minus h, 0 plus h, you can always do that. This is one method which I just showed you in the step 2. But I'm not going to use it. I'm just trying to give you all the flavors how you can do this question. So I'm just using this function, which this one. So when you have x equals 0, what is 0? Minus this equality, for that you will use -2x minus 1, right? So just apply this x tends to 0 in this function -2x minus 1. So -2 into 0 minus 1 it will be. So this is -1. Okay. Now right hand limit is what? X is greater than or equal to 0. X is greater than 0 plus h is greater than 0. So direct value we have for x greater than 0, that this is going to be a -1 already. It is already being found. This is why we have done the step 1 to get the final values. So right hand limit is -1, left hand limit is -1 using the function -2x minus 1. And let us find out the value of the function at 0. What is the value of the function at 0? So 0 we have to check, and just replace it by 0, f0. Okay. That is going to be, I'm just saying, just replace this x by 0. So it will be mod 0 minus mod 0 plus 1. So this is 0 and minus 1. So in these all the three cases, what do you get? -1, -1, -1. So f is continuous here also, x equal to 0. That is how we check the points of discontinuity. Determine if fx equals x square sine 1 by x when x is not equal to 0 and 0 when x is equal to 0 is a continuous function. So when x is not equal to 0, you are going to employ x square sine 1 by x. When x is 0, you are going to apply 0. So we have to determine if this function is continuous or not. Okay. So there are various methods you can apply, which we have discussed earlier in this exercise or discussion also. So x square sine 1 by x is simply x square is another function, sine 1 by x is another function, x square is a polynomial function, sine 1 by x is of course a sine function or a trigonometric function. So they are individually, because they are individually continuous, so multiplication of them of these two will also give you the continuity. So what we do here is, we will, because this is continuous on the real number 9 or real numbers, so we can choose any c or any k. So fc will be what? C square sine 1 by c. If you replace the x value with c, you have to get c square sine 1 by c. So there are certain steps you can take, because there are two steps you have to take, because one is x not equal to 0, one is x equal to 0. So you have to check for both of these functions. So the first function is when we have x equal to c, that is limit x tends to c, we'll apply the limit in both the functions. So limit x tends to c for x square and limit x tends to c for sine 1 by x. So what is the limit x tends to c for x square? It is of course c square, because there is no unprecedented values or undescribable values. So we have c square, here also sine 1 by c. So what do you get? When you apply the limit x tends to c, you get c square sine 1 by c. So when you apply the value of c in the function, you get c square sine 1 by c. That means the function is continuous at all points where x is not equal to 0, because we have chosen some c which is not equal to 0. So limit x tends to c for fx is equal to fc. This is continuity for all points where x is not equal to 0. So now you have to check for x equals 0. Why? See, the sine 1 by x is, if you put 0, it will be 1 by 0, which is infinite. And that we cannot comprehend. We should not do. Now the second step is for x equals 0. That is, we are going to check for x equals 0, because there are two parts of this function. So we have to check the continuity at both of these parts. So c is 0. What is f0? When you apply this f0, you are going to get a 0. f0 is 0. Okay. So we will do the left hand limit and right hand limit and try to find out the left hand limit, right hand limit along with the value of the function here. But the criteria, you can do it, always you can apply. But since at x equal to 0, it is already 0. If you take 0 minus h and 0 plus h, left hand limit, right hand limit, so that will not be a good idea. Let us see sine theta. Sine theta is between minus 1 and 1. What is theta here? Sine 1 by x. So let us multiply both sides by x squared. So you get minus x squared less than equal to x squared sine 1 by x less than equal to, again multiply by x squared. So apply the limits now. I am applying the limit x tends to, we are applying the limit x tends to 0. So when you apply limit x tends to 0, you get this minus x square, of course 0 it will be. And limit x tends to 0, x square sine 1 by x. Here also apply the limit x tends to 0, x square. So the left hand side and right hand side, this is going to be 0, x is 0. This is also 0. So the middle one is between 0 and 0. That is, it has to be equal to 0. Okay. There are two boundary values which are 0, 0. That means the x square sine 1 by x has to be 0. So when you apply limit x tends to 0 for x square sine 1 by x, it is going to be 0. Limit x tends to 0 for x square sine 1 by x is going to be 0. That is, this you have got by putting 0 minus h and 0 plus h, left hand limit, right hand limit. That is also a valid way of doing it. But this is a better way and a shortest way to do it. Basically, limit x tends to 0 minus fx is equal to limit x tends to 0 plus fx, which is the value of the function at 0, which is already given in the question, which is 0 when x is equal to 0. Left hand limit, right hand limit is equal to the value of the function at 0. So this observation, we can conclude that f is continuous at every point of the real line. So f is a continuous function. Both ways we have checked all the values, that is not equal to 0 and equal to 0. So this function, which is a part of two different and individual functions, these are continuous by themselves. Okay. Now this question, find all points of discontinuity of the function. So this ft is already given and t is also given. What you are going to replace in t? T, of course, 1 by x minus 1. So this is the function. ft is 1 by t square plus t minus 2. So this ft is 1 by t square plus t minus 2. Let us find out the factors. So I am making the factor t square plus 2t minus t minus 2. You can write, you can take t common, t plus 2 minus 1 here and t plus 2. So you get t minus 1 and t plus 2. So you have t minus 1 and t plus 2. So these are the factors. Now in order to check the discontinuity, first we have to check that 1 by 0 form should not come. When it will be 0, the denominator, when t minus 1 equal to 0 or t plus 2 equal to 0 or both are 0. So t plus 2 equals to 0, that is t is equal to minus 2, and t minus 1 equal to 0, that is t equals to 1. So these are the points where we have to check, but we cannot check just now. Why? Because t is already given as 1 by x minus 1. So we have to check for x, not for t. Remember? So we have this t minus 1 equals 0, where t is equal to 1, and t plus 2 equals 0, t equals minus 2. So t equals 1 will replace, because t is actually equal to 1 by x minus 1. So 1 by x minus 1 is equal to 1. So you get x minus 1 equal to 1, which is going to be x equals 2. How about t equals minus 2? Minus 2 has to be equated with 1 by x minus 1. So what do you get? Cross multiply minus 2 into minus 2x and plus 2 equals 1. And this is going to give you 2, just take 2 on that side. So minus 2x equals negative 1. Negative, negative cancel. X is equal to 1 by 2. So x equals 2 and x equals half. These are the points of discontinuity. Which one? 2 and half. This is also a way which I am showing you, and the way I did, you can also do like that. Okay, this is all about this discussion. Thank you so much. Take care of yourself.